In this section, I'm going to think about the brain processes that can enable us to understand our feeling that there's a self inside us, and our abilities to imagine how we'd feel about some imaginary situation, and even to imagine ourselves performing non-existent or imaginary actions. To do this, let's go to a somewhat more complex model for cortical areas, and I've explicitly added the somatosensory cortex that detects circumstances in our body positions. So you've got a lot of areas able to develop receptive fields that discriminate between different types of behaviorally significant situations, simple visual object types to very complex combinations of sequences of multimodal sensory inputs. To understand self-awareness, we've got to establish an understanding of how a number of contributing processes work together within this architecture. And the first process, which we discussed a little earlier in the course, is how we acquire an understanding of the words that label emotions, like angry. So within this architecture, I'm going to go over again briefly what happens if you see an angry person. As we discussed before, receptive fields in the amygdala and in some prefrontal areas can recommend placing priorities on different types of behavior, and if a recommendation of this type is accepted, it's experienced as the corresponding emotion. If you see an angry person, receptive fields are going to be detected within the visual inputs derived from looking at them. More complex receptive fields will be detected by combining sensory inputs from all sorts of different sources. Then suppose that in addition you hear the word angry. This will activate columns in the auditory cortex, and there's going to therefore be simultaneous activity of these auditory columns and other cortical columns, which creates the association between the word and the meaning on the basis of frequent past simultaneous activity, as we've discussed before. Now, let's suppose that you are angry. In this case, you may be getting visual input from looking at your own body, proprioceptive input from the position of your body. And again, more complex receptive fields will be detected within information derived from the overall situation. And receptive fields in the amygdala that are recommending aggressive behaviors will also be detected. Suppose again that you hear the words, "You're angry." The word angry is now heard at the same time as you are feeling angry, at a time when your attention is being directed towards yourself by the words. So auditory columns activated in response to the word can acquire recommendation strengths in favor of indirectly activating all sorts of information derived from self-observation, including personal emotion, and again the general circumstances. So later, when you hear the word angry, there are indirect activation recommendation strengths in favor of both columns active in the past when other people were angry and columns active when you yourself were angry, including some with recommendation strengths in favor of aggressive behaviors, in other words, feeling angry. Now, the next process that's relevant to self-awareness, and perhaps it's the key process, is how we learn our names. Once again, using this cortical architecture, think about a situation in which a small child is told, "You are Billy," or "Your name is Billy." Attention is being directed to self. So there will probably be receptive fields detected within visual information derived from looking at their own body. Receptive fields within body position will also be detected, plus more complex receptive fields correlating with circumstances and emotions. All these columns will be active at the same time as columns detected within hearing the name. Now, in general, each time the name is heard, a different population of columns will be active. But on average, some columns could be active more often than others. So when the word Billy is heard after many such occasions, some visual columns will be indirectly activated, containing a high proportion of columns with self-body appearance information, along with columns containing information about body position directly. columns containing information derived from groups of objects often present when the name was heard, the very complex circumstances when the name was heard, and even the emotions. So hearing the word Billy can activate a population of columns that's a kind of weighted average of the populations active when the name was heard in the past. So the subjective experience will be of a kind of average of past body positions, moods, visual experiences of self-body, and so on. And that, of course, will make available some behavioral recommendations that were often present. Now let's think about what happens when this boy called Billy sees another boy and at the same time hears the word boy. Once again, there'll be auditory columns active at the same time as a broad population of columns in other areas. So when the word is heard after a number of such experiences, it will indirectly activate a population that's a kind of weighted average of columns active on past occasions when Billy was looking at other boys. So there's what I'll call a Billy population and also a boy population. Now, think about what happens when the child hears the words, Billy is a boy. The columns in the two populations are active at similar times and can therefore acquire recommendation strengths in favour of activating each other. And in particular, the columns present in the word Billy can acquire recommendation strengths in favour of columns active when Billy was looking at other boys. So there's two types of what I'll call Billy populations. One I'll call the me population. Not quite semantically exact, but it's a useful label. This me population is a weighted average of the columns active in the past when Billy's attention was directed to himself and the word Billy was heard. The second population is what I'll call the I population. Again, a little inaccurate semantically, but labeling the population often active when hearing Billy is a boy. So it has a fair amount of overlap with the me population, but it incorporates some information derived from Billy looking at other boys, obviously from an outside perspective. Early on, these two populations are initiated by use of the name Billy, but over time, the columns in these populations are often active at the same time as each other, so subsets of a population may gain enough recommendation strength to activate the whole population. So if this is the me population, and if a subset of that population, which I'll label by circling the columns, if that subset happened to be activated as part of some larger population activated in the course of sensory processing, then the subset could have enough recommendation strength to drive indirect activation of the full me population, at a different phase of frequency modulation perhaps. Different subsets could often occur in the course of sensory experience, so the me or the I populations could be activated in many different circumstances. Furthermore, if the activation of a self-population like this is followed by positive consequences, the recommendation strength in favour of its activation will increase, resulting in more frequent activation. So over time, self-populations could develop which tend to be activated fairly frequently. So what will be the subjective experience of a population like this? Well, let's suppose that the columns in red represent the pattern of activation when you're paying attention to yourself on one specific occasion. In other words, the current visual, somatosensory, emotion recommending and circumstance receptive field detections that are currently being made. The pink columns represent a me population that's been indirectly activated at a different phase of frequency modulation, so the two populations are kept separate. Apart from the absence of column activations close to sensory inputs, this me population could be a population activated directly if attention was focused on self in the right circumstances. So the subjective experience when a me or an I population is active will be very similar to the subjective experience when focusing attention on self. So there's going to be a feeling that a self is present, but this self is a weighted average of past selves. And in the illustrated situation, there could be two selves active. One, the current self in the current situation, the other, the weighted average. So what's the behavioral value of these self-activations? Well, in the diagram, you've still got the red current self population and the pale pink me population, but I've added a darker pink population representing the results of processing external sensory inputs from the environment. So there's three populations in some areas, again at different phases of frequency modulation in areas where they overlap. Receptive fields could be detected that combine receptive field detections within current self and detections within current sensory inputs, and they would have recommendation strengths in favor of currently appropriate behaviors. However, the weighted average self draws on much more extensive sources of information, and in some situations, the recommendations derived from combining current sensory inputs with a me or an I population may be even more appropriate. Note further that sensory inputs or other column activity combined with the current self population could recommend speech behaviors, but so could sensory inputs combined with a weighted average self, although in both cases it could result in just activation of auditory columns as if speech had been heard. And if the weighted average self generated auditory column activity and it was released to the current self population, this will be subjectively experienced as the current self hearing words spoken by that weighted average self. And of course the information could flow in the opposite direction, leading to a subjective experience as if the weighted average self was hearing current self speech. Hence the experiences of conversations with self. So populations can exist that are weighted averages of past self. But other people also have names. So a similar process across a number of experiences of another person could lead to a population that's often been active in the past when observing that person. If that kind of population was activated indirectly, and if it was combined with receptive fields detected within current sensory inputs, recommendation strengths could develop that can be interpreted as describing the probable behaviors of the other person in current circumstances. In other words, a mental model of the other person. So, in summary, the use of personal names can lead to the activations of populations that correspond with weighted averages of past occasions when attention was directed to self. The me population is experienced as if there's an extra self present within. The I population is similar, but incorporates information which gives the apparent experience of looking at self from the outside, a perspective that rarely occurs in reality, but can be useful for determining appropriate behavior within some physical environments. But perhaps it's for social behaviors that self-awareness processes are most needed to determine appropriate behaviors. And it's important to note that these self-awareness behaviors are learned. And a researcher called Julian Jaynes argued that human beings only began to learn them about 2,500 years ago. And prior to that, humans had to use other cognitive techniques to determine appropriate behaviors in complex social situations.